Hey guys, so today we're going to go over something that kind of stems from the regression video we just did with talking about correlation coefficient. So pretty much the point of the correlation coefficient is to tell you two things. One, the sign, like the direction of the relationship between x and y, whether or not it's a positive or a negative relationship, and also the strength, how good of a fit that model is to the data that you found. Because remember in our last video, when we talked about plotting a line of best fit between x and y, oftentimes it's not going to be a perfect one-to-one cause and effect relationship. There's going to be some error, there's going to be some variability, some residuals between what you find on the line of best fit when you plug in an x and it gives you a y hat output versus what you actually see in the real world, what you plotted on the line and everything. So the correlation coefficient kind of gives you a good overall summary of how strong of a fit that line is to the data and also what direction that relationship goes. So it's known as R, that's the variable used for correlation coefficient. I've seen it as well as RXY, so make sure depending on what class you're in that you're using the proper variable for it, but I've just typically seen it as R, and it's important to know that it is a number between -1 and +1. So if at some point you're doing correlation coefficient calculation, you get anything that's less than -1 or more than +1, you did something wrong. It has to be between -1 and +1. So the sign of your correlation coefficient, of your R, whether or not it's negative or positive, is going to tell you the direction. So if it's positive, that means that it's going to be a positive relationship. So as x goes up, y goes up. And we'll kind of show an example of what that will look like on a scatter plot, but it's a direct relationship. It's a positive relationship. Whereas negative means as one goes up, the other one goes down. It's an inverse relationship, and that's what the negative means. So if you see an RXY or an R that's negative, it's a negative or inverse relationship. And if it's positive, that means it's a positive or direct relationship. So however close to 1, I don't know what the best phrase for it is, so I'll just say the closeness to 1 involved with R is going to tell you the strength of that line. So if I have a +1, so let's go ahead and talk about these right here, where I have a perfect one-to-one cause and effect. As one goes up, the other one goes up by the same amount every single time. It's a perfect relationship. So I go into the wild and I run data on whatever my x is, whatever my y is, it doesn't really matter, but I plot my x and my y points based on my sample, and it's just this perfect little line right here. Well, before, when all the variation was about that line between the weight and the height in my previous example, you tried to draw the line of best fit, and it was the best fit because it wasn't perfect. Here, seems pretty perfect to me. I can draw a line straight through that data, except when I mess up a little there, but that's a perfect one-to-one relationship. And so this is going to be an example where R is going to equal +1. And the reason it's positive is that, note, as an x value goes up, so as I go, here's 0 on the x right here, as I start to go further and further to the right on my x, the y's go up along with it, thus creating this positive relationship. So that's what the +1 tells you. So the positive is the direction, the 1 is the strength between, the strength of the data fitting to the line. Whereas with right here, we're going to have R equals -1. Because you can see that it's the same situation right here, except it's going downward, right? So it's still perfectly fitted to the line, except it's as x increases, y actually decreases. So that just means it's a negative relationship, so you can kind of see the lessons we learned from over here correlate directly over here. So a moderate relationship between the two, let's say we'll just keep the positive correlations here, the negative correlations here. So a moderate might look like something like the weight and height example that we did, where you can tell that it's trending upward, and we'll draw a line of best fit through it, but there's variation about the line. So this isn't, predicted. It's not going to be close to 0, because 0 just means there's no relationship whatsoever. So it might be somewhere between 0.5 and 1, something like that. So we'll say, R equals, let's say 0.75 right here. It's probably not actually the case, but it at least shows you it's further away from 1 as those dots get further away from the line. And same situation here, where we have our x and our y, and we have just scattered variation, but it trends downward. It's still going to be, about the same strength to the line, so probably about 0.75. But since it goes downward as the x's increase, the y's decrease, we're going to call that a negative 0.75 right there. And again, the 0.75, that's not some magic number. It's just showing you that it's further away from 1, but not 0, because there's a clear relationship going on. Finally, when we're talking about there being no relationship at all, I always heard that it's like a shotgun blast, where just at any given x, we can have any given y, and there's no discernible relationship whatever. Try and draw a line of best fit through that. I don't know how to do that. So you can't draw a line of best fit. R is going to equal 0 in this situation because there's no discernible relationship between them whatsoever. And you might see some situations where it looks like it's a shotgun blast, so you think it's 0, but it might compare it against something that looks more like this, where it's truly at any given X, there's just a random Y, and there's certainly no line of best fit right here. This is more of a true 0. This one could be maybe a 0.1 or something like that. Again, that's not some number I knew. It's just, you know, maybe it's trending upward just a little bit. There's no way of really telling without doing the actual calculation itself. This is definitely a 0 right here. So when you're comparing the two, this is certainly a weaker association than this one right here. So that's a good overview of correlation coefficient. You know, there are calculations involved with how to actually find that. Sometimes you'll have charts that you can use to just look at what it might be, especially if you're given an Excel output or a Minitab output. But just kind of to wrap your head around the concept of correlation coefficient, this should be pretty good. So I hope that helped.